All right, let's take a look at problem 3, analyzing a normal distribution. The heights of adult American males are approximately normally distributed with mean of 69.5 inches and a standard deviation of 2.5 inches. And if you remember in problem 2, we learned how to put this on a table. It says what percent of adult American males are between 67 and 74.5 inches tall? And if you remember from the first page, they gave us those percentage rankings. And so here they are right here. We know a 1 standard deviation is between 34 and 34%, 2 is 13.5, and so on and so forth. So it says for the first question, it says what percent of adult American males are between 67 inches and 74.5 inches tall? So we first have to draw our standard deviation. We know that the mean is 69.5, and we know that each one is 2.5, so I'm going to add 2.5 here and subtract 2.5 here. Then I add 2.5 to this one, and I subtract 2.5 from this one. Then I add 2.5 here, and I subtract 2.5 here. And that gives me all of my data points for my standard deviation from -3, -2, -1 to the mean, to 1, 2, and 3 standard deviations of the mean. All right, so then now I want to see, it says what percentage of Americans are between 67 and 74.5. And so that's between -1 standard deviations of the mean to 2 standard deviations of the mean. Correct? Correct. So I add all of these up. I get 34% plus 34% plus 13.5%. which gives me about, and they did it as decimals first, which is fine because either way I can convert it back into a percent. 0.815 or 82% of the adult American males are between 67 and 74.5 inches tall. All right, let's look at B now. It says in a group of 2,000 adult American males, about how many would you expect to be taller than 6 feet or 72 inches? And so using that same information that we got before, this is the same chart, but this time I want 6 feet, so this is 6 feet and higher. I'm going to use this data here. So if it's greater than, I have it says because the graph is symmetric about the mean, the right half of the distribution contains 50% of the data. So we know this is 50% of the data. If you subtract everything between 69.5 and 72 between the right half, only part of the distribution that is greater than 72 remains. So you get this 50 minus this 34, which is 16. You would expect 16% of 2,000 adult American males to be taller than 72. Or you could find out the exact amount. So 0.16, which is just this as percent as a decimal, times 2,000 is 320. So 320 will be over 6 feet tall. Another way of thinking about it, instead of subtracting, which we could do, we could subtract. Why don't we just add this here? So we can just add this 13.5 and this 2.35, and we get about 16 as well. So it's the exact same answer. Let's try it on our own now. It says the scores of the Algebra 2 final are approximately normally distributed. And the reason, and I'm sorry, just going back here, the reason they subtract is because all of the percentage is not here. So I have this little extra percent that's not there, and that's why we would round our answer. All right, going back. Sorry about that. The scores on the Algebra 2 final are approximately normally distributed with a mean of 150 and a standard deviation of 15. Let me put that down really quick before I forget. So my mean is 150 and the standard deviation is 15. So that's going to be, we'll use our calculator. So 150 plus 15 is 165. 165 plus 15 is 180. Oops. And 180 plus 15 is 195. Okay, so now I'm going to subtract instead this time. So 150 minus 15 is 135. 135 minus 15 is 120. And I'm sorry, I'm going to not do it for this one. 120 minus 115, minus 15 is 105. Okay, so here's my mean. This is plus 1, plus 2, plus 3. This is minus 1, minus 2, minus 3 of the mean. Okay. Now it says what percentage of students who took the test scores scored above 180. Alright, so 180 is right here, which is 2 standard deviations of the mean. And I'm not going to try to draw the chart, guys. Please forgive me, but I'm not. Let's go here. Try first. So this lets me know. Then 2 standard deviations of the mean. Okay, so 2 standard deviations of the mean is going to be everything right here. So we can try the subtraction method because we can make sure that we have everything included. So that would be for part A right here. A would be this 50% minus 34 minus, I should know this by heart, but I don't. I'm sorry. 13.5. So let's see what we get. 50 minus 34 minus 13, 0.5. It's 2.5%. So 2.5%. Go back to the question. See what we were answering. 2.5% students scored above 180. Okay. If 250 students took the final exam, approximately how many scored above 135? So let me go back to my chart. 135. Oh, that's everything. So that's 50% plus 34, right? So 50% plus 34, and I'm going to do that one in my head, 84%. So 84%, and how many students do they want us to calculate for? For 250. So 250 times 0.85, because I changed it into a decimal, will give me, what's that point? 85. Was it 85? No, it's supposed to be 84. I'm sorry, that's why I was confused. Confused my own self. 84. 210 students. Wow. So, if 250 students took the test, took the final exam, approximately 210 of them would have scored above 135. Alright. Last but not least, if 13.6% of the students received a B on the final exam, how can you describe their scores? Explain. So going back to my chart, I know that this is between I'm sorry. I'm so sorry. So let's say this is between 34 and 34. Oops. This is 13.5. And this is 13.5. And this is 2 point something. And that's 2.35. Okay. So if, Go back to the question. Okay, so if 13.6% of the students receive a B on the final, how would you describe their scores? Explain. So, here again, assuming, we will have to assume this, that this is the higher side of the grade. Well, I mean, of course it's the higher side. So let's say that this is an A. I don't know what an A is for this score. And let's say that this would then have to be a B. I'm assuming that this score here is the B range because over here is perfection, so this is an A. So I would say that to describe a B on this exam, you would have to get a 165 to 180 on this exam. So for C, the scores would range between 165 to 180 for B. And I hope this helps.